Okay, in lesson 22, we start heading a little closer to the standard algorithm. We've been doing a lot of estimation, a lot of chunking as far as dividing goes. Now we're going to head. All right. So first thing, let's go ahead and write it in a standard algorithm, which would be 485 divided by 15. And we're going to be taking 15 because 15 cannot go into 400s, but 15 can go into 48 tens. So let's go ahead and skip count by 15 to see how many times it can get. Because 15 would be the first multiple. 15 plus 15 gives us 30, and that'd be the second multiple. Plus 15 again would be 45, and that'd be the third multiple. And we can see we only need to take it as far as we need it. And 45 is lower than 48, so we know that was the third multiple. We can get 3 15s out of 48. So 3 times 15 is 45, and we have 3 as remainder. Now 15 cannot go into 3 10s, but when we regroup by bringing a 5 down, we now have 35 ones. So 15 goes in 35 ones, we can see that it will go 2 times. And I'm writing that right above the 2, excuse me, right above the 5, and 2 times 15 is 30 with a remainder of 5. Now to check this, we do our multiplication of 32 times 15. 5 times 2 is 10. 5 times 3 is 15. 1 is 16. We're going to X out the 1s, and we're going to put a 0 there. 1 times 2 is 2. 1 times 3 is 3. And we end up with 480. Plus we have to add our 5 remainder in, which gives us 485. Now for the next one, we have 700 divided by 21. And once again, I'm looking at the first 2 digits, and I can see the first 2 digits are more than our divisor. So I'm going to skip count 21, which is our first multiple, plus 21 is 42. So that's our second multiple, plus 21 would be 63. And we can see that would be our third multiple. So I can see that 21 will go into 70 tens 3 times without going over, because 3 times 21 is 63 that we work down here. And we subtract them, we end up with 7. Now 21 cannot go into 7 tens, but 21 can go into 71s. And 21 will go into 71s 3 times again. And 3 times 21 will give us 63 again, with a remainder of 7. So when we multiply it, I'm going to go 21 times 33. 3 times 1 is 3. 3 times 2 is 6. Now I'm done with the 1, so put a 0. 3 times 1 is 3. 3 times 2 is 6. And we end up with 693. We have to add on D. We have 399 divided by 31. And we can tell right off the bat 31 plus 31 is going to be 62, which will be the second multiple. So we're only going to be able to get 31 out of that 39. And when we subtract, we have 8 left. So we cannot take 31 into 8 tens, so we regroup to 89 ones. And if I add another 31 here, that's going to be 93, which would be the third multiple. And that's going to be too large, so we're going to stick with the second multiple, 62, and we're going to end up with 27. So we ended up with 12 remainder, 27. I'm going to check this. 12 times 31, and I'm going to end up with 12. Place our 0 because we're done with our 1s. 3 times 2 is 6. 3 times 1 is 3. And we end up with 372. We add 27 to it for our remainder, and we have 399, which checks. On E, we have 820 divided by 42, and I can see 42 plus 42 is going to be 84. That's going to be too much as a second multiple, so we're only going to be able to take 42 out of that 82. That leaves us 40. Now, 42 cannot go into 41s, so we're coming down. Oh, now we got 400. Well, at this point, I could keep on skip counting. But you know what? I'm going to do 42 times 8, just because it's close. And 8 times 2 is 16. 8 times 4 is 32. And 1 is 33. So 9 would be another 42. That's going to be 8, 7, 378. That would be our 9th multiple. So let's go ahead and go with 9. 9 times 42, from what you see up here, was 378. And we have to regroup to 3. Brings that to 10. Regroup that to a 9. That to 10. We end up with 2, 2. So we have a remainder 22. 19 remainder 22. Let's check and see if that worked. 42 times 19. 9 times 2 is 18. Carry 1. 9 times 4 is 36. 137. Now we're done with our ones. 1 times 2 is 2. 1 times 4 is 4. And we end up with 8, 9, 798. We're going to add 22 in there. That's going to be 10, 10, 12, and 820. So it checks. Our last one like this, we have 908 divided by 56. And I can see right off the bat, 56 plus 56 is going to give us 112. So the first multiple will be 56, second multiple will be 112. So I know 90, I only can get 1 out of it. So I'm going to go 56. And when I regroup, I'm going to end up with 34. Now I have 8. Now I can keep skip counting here. 56 would be 8, 6, 168, which would be a third multiple. 56 would be 14, 12, 224, which would be the fourth multiple. We can do 56 again. That'd be 10, 8, 280 for the fifth multiple. And we do 56 again. 336 for the sixth multiple. So we can see we'd end up going 6 multiples, and we know the multiplication would be 336. And when we subtract it, we end up with 2. We end up with 12 remainder. Now let's go ahead and check it. We have 56 times 16. 6 times 6 is 36. 6 times 5 is 30, and 3 would be 33. Place that 0 in there, 6 and a 5. We have 6, 9, and 896. We have a 12 remaining, be 80908. So it worked out. Checks. Number 2, when dividing 878 by 31, a student finds a quotient of 28, remainder of 11. Check the student's work to use the check and find the error in the solution. So first off, what they're saying is they had 878, and they divided it by 31, and they got 28, remainder 11. So in order to check this, we're going to take 28 times 31, and we're going to end up with 28, 0, 24, and that'd be 6, 7, 8. 840, which would be 8, 6, 8. And then they're adding 11, which would be for the remainder, that'd be 9, 7, 879. So they're off by 1. So let's see what actually could have happened. It says, see if we can figure out where they did their error. So if we had 878 divided by 31, if I skip count 31 plus 31, that's going to be 62 as a second multiple. And 31 would be 93 as a third multiple. So we can see it's only going to be 2, and that's going to be 62. When I subtract, that's going to be 25. Then they're going to bring the next multiple back down, which would be 8. So at this point, if I keep adding 31s, be 124, which would be the fourth multiple, and another 31, be 155 for the fifth multiple, another 31, be 186 for the sixth multiple, another 31, be 7, 11, 217 for the seventh multiple, another 31 would be 248 for the eighth multiple. So we know it's going to be the eighth multiple and 248. When we subtract, we should end up 10. So the remainder of 10, you can see somehow when they subtracted, they made a mistake. They end up with a remainder of 11. A baker was going to arrange 432 desserts into rows of 28. The baker divides 432 by 28 and gets a quotient of 15, remainder 12. Explain what the quotient and the remainder represent. Okay, so let's take a look. Let's do a tape diagram so we can see it. So here's our tape diagram. This here, 432, that represents the desserts. And this is actually the dividend. Now it says into rows of 28. So these rows of 28 right here, these represent rows. Now it says a quotient of 15. So there'd be 15 in each row. And over here, they would have 12, and that's the remainder. And that is extra desserts. So from the questions, explain what the quotient remainder represent. The quotient over here represents number of desserts in each row, and the remainder represents extra desserts not in rows.